So now we're ready to look at exponential functions. An exponential function, in short, is any function where the variable shows up only in the exponent and nowhere else. So for example, in part A we have f of x equals 7 times 2.4 to the x. And we are asked to evaluate this function at a couple of different, more or less random values. In this case, just 3 and 4. So, to calculate f of 3, we need to plug 3 in everywhere we see an x. So that's going to give us 7 times 2.4 cubed. So practice plugging this into your calculator. If you are using your TI-83 or 84, something like that, the way you would enter this into the calculator would be 7 times, and then you don't have to put parentheses here, but it's good practice, 2.4, then we close the parentheses and raise this to the third power. So one thing to keep in mind is that the 2.4 is the only thing that's getting raised to the third power here, not the 7, just the 2.4. Or if you want, you can calculate the 2.4 raised to the third power first and then multiply the result by 7. That's going to give you the same answer. In either case, though, the answer is 96.77. We were asked to round to 2 decimal places in this problem. Okay, so in a similar way, if we want f of 4, that's 7 times 2.4 raised to the 4th power. We would enter that into the calculator in a very similar way. Go ahead and do that and make sure, double check that you get 232.24. Okay, so that's just a basic example. In part B we have an example that's a little more complicated because our exponent doesn't have just an x, it has 2.6 times x. So the basic idea is that anything we plug into this function, we first have to multiply the input by 2.6 and that becomes our exponent. So for example, if I plug in 1 times 2.6 is 2.6. So here I just get 4 times 3.2 raised to the 2.6. So if I plug that into the calculator, this is going to give me 82.309, rounding to 2 decimal places, that's 82.31. Okay. So now, what if I plug in 2 into this function? Well, again, the very first thing that happens is that if I plug 2 into this, I have to calculate 2.6 times 2. And so that's going to give me, so I get 4 times 3.2, and then 2.6 times 2 is 5.2. So 5.2 is what I'm going to use as the exponent here. Then I plug this into my calculator, and this is going to give me 1,693.71. Okay, so that's the basic idea. Let's take a look at a few more examples. In part C, we have this function, I have written here f of x, but our variable here is actually t, so let me change that really quickly. F of t. Okay, so the first thing I want to calculate is f of 5, so I take 240 times 1.052 raised to the 5th. Again, if you want to enter that into the calculator, what you could do is type 240 times, it's good practice to put the parentheses in here, 1.052, and then raise it to the 5th power. And then calculating that, it's going to give you 309.24, rounded to 2 decimal places. Then f of 8 is calculated in exactly the same way. I just replace the 5 with an 8, and then running that through my calculator, I get 360.03. Okay, so far so good. Let's take a look at the last couple of examples. D is another example where my exponent is not simply a variable. It's a little more complicated than that. So whatever I plug into this function, I first have to multiply that by 12, and the result is what I'm going to use as my exponent. So when I plug in 4, for instance, I'm going to get 48 as my exponent. So this is going to give me 375 times 1.0058 raised to the 48. Okay, go ahead and plug that into the calculator and confirm that you are able to get 494.98. If you didn't get that, check over your steps, try to figure out where your mistake was. If you can't figure it out, then let me know and then we can work through it. But okay, if I plug in 10 now, calculate f of 10, this is going to give me 375 times 1.0058, but now my exponent is 12 times 10, which is 120. And that's going to give me 750.63. Okay, so this next example might look a little strange. It has this e in here for our base. The notes explain that e is a constant, kind of like pi, and that it goes on forever without repeating, but it's approximately 2.718. But if I want to do calculations involving e, then your calculator happens to have an e to the x button. And if you refer to the notes, it explains how you find this e to the x function. But basically it's on the left-hand side, 3 buttons up, you'll see an ln button, and above that in orange or yellow you'll see e to the x. So basically you'll hit second and then that ln button, and that brings up the e to the x function. Okay, so in part E, if I want to calculate f of 3, I would take 184 times e. Now my exponent is really 0.061 times t. So that's 0.061 times 3. So my exponent here is 0.183. Now, when I plug that into the calculator, I'm going to write 184 times, and then I hit that e to the x button, and that puts in this, e raised to, and then it puts a parenthesis. So I just fill in 0.183, close the parenthesis, and hit enter. And this is going to give me a result of 220.95. Okay, so I calculate f of 7 in basically the same way. 184e. I need to figure out what my exponent is, but that's 0.061 times 7. Or in other words, 0.427. So I plug this into the calculator and get 282.01. Okay, so that's basically a quick overview of how exponential functions work.